This is an overview of research that investigates the use of NASA's ICESat2 satellite to detect harmful algal blooms across the Finger Lakes of New York State. My name is Felicia Fiacco, and I'm a student in the Environmental Resources Engineering Department at SUNY College of Environmental Science and Forestry. I am working with ERE professor Dr. Lewis McCaffrey. So some background about NASA's ICESat2. The satellite uses spaceborne LiDAR, which means it emits pulses of photons, actually 10,000 of them every second, and it records the time it takes these photons to leave the satellite, bounce off the surface of the Earth, and return to the receiver. By recording these round-trip travel times, the satellite measures distances and elevations, and it can do this for clouds, glaciers, tree canopy heights, but for this research, we're using it to illustrate bathymetric profiles and water surface elevations for inland bodies of water. So why should we care about monitoring harmful algal blooms? Well, HABs have the ability to produce toxins that are harmful to the environment, and there's been an increase in HAB reports across the Finger Lakes region. And so we're exploring the use of spaceborne LiDAR as an additional method for detecting harmful algal blooms. So the hypothesis of our study is that harmful algal bloom presence can be detected through reductions in photon depths captured by ICESat2. So when there are not HABs at a lake, photons should be able to penetrate pretty deeply into the water. And so in this way, ICESat2 photon returns can illustrate typical bathymetric profiles, in that as we move further away from the lake shoreline, the photons are illustrating that deepening lake bed topography. When there are HABs at a lake, there's more surface scum and turbidity, and so the photons aren't able to penetrate as deeply, and we're missing that typical bathymetric profile that we do see when there are not harmful algal blooms at a lake. Primary analyses of this study involve developing a Python automation tool. What this tool does is it queries ICESat2 track data across all 11 Finger Lakes by using the web-based platform called Slide Rule Earth. The image here shows what the ICESat2 track data looks like for Seneca and Cayuga Lakes. The automation then uses the stored satellite data and temporally and spatially matches it with the exact locations and dates of HAB reports for each water body. This allowed for the comparison of photon depths between locations where there were reported HABs and locations where there were not. So these are two examples for Seneca Lake. On the left-hand side, we have a HAB present location. We also see that photons don't penetrate much deeper than the lake surface. On the right-hand side, however, at a location where there was not a reported HAB, we see a bathymetric profile, and the maximum photon depth is much deeper compared to when there is a harmful algal bloom. So right now we're conducting statistical analyses to evaluate the maximum reliable photon depths between HAB present and HAB absent photon datasets. This research aims to present ICESat2 as an opportunity to expand and refine harmful algal bloom detection techniques. And thank you all for listening.